Hello, my name is Saket. I'm a final year student from CSC department. This video is about the tech talk on software testing methodologies on topic data flow testing. Now let us discuss about the following. Data flow testing is the name given to the family of testing strategies based on selecting paths through the program's control flow in order to explore sequences of events related to the status of data objects. For example, picking enough paths to ensure that every data object has been initialized prior to the use or that all defined objects have been used for something. Now, the major motivation is that it is our belief that just as one would not feel confident about a program without executing every statement in it as a part of some test. One should not feel confident about a program without having seen the effect of using the value produced by each and every computation. Now, there are basically two types of data flow machines with the different architectures. Von Neumann machines, multi-instruction or multi-data machines. Von Neumann machine architecture. Most computers today are von Neumann machines. This architecture features interchangeable storage of instructions and data in the same memory units. Now, the von Neumann machine architecture executes one instruction at a time in this following instruction sequence. Now, it fetches instruction from memory, interprets instruction, fetches the operands, process or executes the following instructions, stores the result, and then increments the program counter, and then goes to the step one to repeat until all the instructions are executed. Now, multi-instruction, multi-data machines, MIMD architecture. These machines can fetch several instructions and objects in parallel. They can also do arithmetic and logic operations simultaneously on different data objects. The decision of how to sequence them depends on the compiler. The bug assumption of our data flow testing strategies is that control flow is generally corrected there and that something has gone wrong with the software so that the data objects are not available when they should be, or silly things are being done on the data to the data objects. Also, if there is a control flow problem, we expect it to have symptoms that can be detected by data flow analysis. Although we will be doing data flow testing, we won't be using the data flow graphs as such. Rather, we'll use the ordinary control flow graphs annotated to show what happens to the data objects of interest at that moment. Now, let us discuss about the data flow graphs. The data flow graph is a graph consisting of the nodes and directed links. We will use we'll use an control graph to show what happens to the data objects of interest at that moment. Our objective is to expose deviations between the data flows we have and the data flows we want. Now, data objects can be created, killed, and used. They can be used in two distinct ways. In the calculation as a part of the control flow predicate. The following symbols denote these possibilities. D means defined, created, initialized, etc. Killed or undefined. K. K means usage. U is used for used for something like C used in calculations, P used in predicate. Now, any object is defined explicitly when it comes up when it appears in the data declaration, or implicitly when it appears on the left hand side of the assignment. It is also to be used to mean that a file has been opened. A dynamically allocated object has been allocated. Now something is pushed onto the stack, a record written. Now an object is killed or undefined when it is released or otherwise made unavailable. When its contents are no longer known with certitude, with absolute certainty. Now, release of dynamically allocated objects back to the availability of pool. Return of records. the old top of the stack after it is popped. An assignment statement can kill or redefine immediately. For example, if had been previously defined and we do a new assignment such as a is equal to 17, we have killed a's previous values and redefined a. Usage. A variable is used for computation when it appears on the right hand side of the assignment statement. A file record is read or written. It is used in predicate when it appears directly in the predicate. Data flow anomalies. An anomaly is denoted by two character sequence of actions. For example, KU means that the object is killed and then used, whereas DD means that the object is defined twice without an intervening usage. Now, what is an anomaly is depend on the application. There are 9 possible two-letter combinations for D, K, and U. Some are bugs, where some are suspicious, and some are okay. DD, probably harmless but suspicious. Why define the object twice without an intervening usage? DK, probably a bug. Why define the object without using it? DU, the normal case, the object is defined and then used. KD, normal situation, an object is killed and then redefined. KK, harmless but probably a buggy. Did you want to be sure it was really killed? KU, a bug, the object does not exist. UD, usually not a bug because the language permits reassignment at almost any time. UK, normal situation. UU, normal situation. Now, in addition to two-letter situations, there are 6 single-letter situations. We will use a leading dash to mean that nothing of interest occurs prior to the action noted along with the entry-exit path of interest. A trailing dash to mean that nothing happens after the point of interest to exit. They the possible anomalies are k possibly anomalous because for the entrance to this point on the path the variable has not been defined. We are killing the variable that does not exist. D, okay, this is just the first definition along this path. U, possibly anomalous if the variable is not defined and has been previously defined. Okay, not anomalous. The last thing done in this path was to kill the variable. D, uh, possibly anomalous. The variable was defined and not used in this path, but this could be global definition. U dash, not anomalous. The variable was used but not killed on this path along this sequence and is not anomalous. Now, the data flow anomaly model prescribes that the object can be in 1 hour distance, distinct, one of the 4 distinct states. K, undefined. D, defined. U, has been used. A, anomalous. These capital letters denote the state of the variable and should not be confused with the program action denoted by the lower cases. Unforgiving data flow anomaly flow graph. Unforgiving model in which once a variable becomes anomalous, it can never return to the state of grace. The following diagram depicts an anomalous state graph. Now assume that the variable starts with the k state. Okay, this is the description about the following diagram. Now, in principle, you must create a new definition of data flow anomaly in each situation. You must at least verify that the anomaly definition behind the theory or the embedded in the data flow anomaly test tool is appropriate to your situation. Now the graph has 3 normal and 3 anomalous state, and uh, she considers that the KK sequence is not to be anomalous. The difference between this graph and the previous graph is that the redemption is possible. A proper action from any of the 3 anomalous states returns the variable to the useful working state. Now, static analysis is the analysis done on the source code without actually executing it. Dynamic analysis is done on the fly as the program is being executed and is based on the intermediate values that result from the program's execution. If a problem such as the data flow anomaly can be detected by static analysis method, then it does not belong in the testing. There are actually a lot more static analysis for data flow analysis for data flow anomalies. Now, there are many things which current notions of static analysis are inadequate. They are dead variables arrays. record pointers, and dynamic subroutine function names in the call, and false anomalies. Okay, although static analysis methods have limits, they are worth using and continuing a trend in the language processor design has been better static analysis method, especially for the data flow anomaly detection. That's good because it means there's less for us to do as testers, and we have far too much to do as it is. Thanks for watching.